Morning for AI for Good, the October edition. I think we're still in October. So today I wanted to talk about deep research. So the presentation is called The State of Deep Research. And so many of you probably have probably use deep research already. If you use ChatGPT, Claude, and so on, you often have the deep research option in there, or sometimes it's by default, but sometimes you just have to click a button and get deep research. So we're going to see what it is and what is behind these kind of models, and look at some the benchmarks that they use to measure the effectiveness of deep research, and also the risk and limitation of deep research. Okay. This is the outline. So what is deep research? So the best way is to ask the deep researchers, right? So I ask Claude, OpenAI, Gemini, and Perplexity. So we won't go over all the answers, but so this is the answer from Claude. So I just ask Claude, so define me what is deep research or deep research agents. So what Claude is saying is deep research agents are AI systems that can autonomously gather information from various sources, synthesize findings, identify patterns, and generate insights, tasks typically requiring significant human expertise and time. Okay? These agents can parse complex research questions, create comprehensive research plans, retrieve and analyze relevant documents, extract key information, and synthesize everything into coherent narratives. The term deep research agents generally refers to the broader concept of building custom research agents using AI models like Claude rather than a specific Anthropic product. Okay. So the specific Anthropic product is Claude Research or Claude Advanced Research. So it's built in Anthropic. So it was launched in earlier this year. So you have to choose the research mode, right, in the Claude window. And research mode runs multiple connected researches, refining queries as it goes, and delivers structured citation-backed answers in minutes. Okay. Advanced research extends this with up to 45 minutes of autonomous investigation across hundreds of sources, breaking down complex tasks and compiling thorough reports. Okay, so you don't get the results right away. For often you have to wait, depending on your query, you wait 1-2 minutes, or sometimes it can be here to say up to 45 minutes. Claude Research Agent use a multi-agent approach with a lead orchestrator that coordinates specialized search and citation sub-agents working in parallel. Okay? In Anthropic's internal test, this multi-agent outperformed a standalone like Claude model, a Claude Opus 4 by 90.2%. So of course so it's available to Max subscribers, right, for the advanced model. I think you can still have access to basic research for free. Okay, so this is deep research according to AI. I won't read the whole thing, just the beginning. Deep research is designed to take a single high-level prompt and then autonomously perform multi-step research. Browsing the web, reading text, images, PDFs, analyzing, synthesizing, or producing a structured report with citation. Well, it's just very similar to what Claude was saying. So that's what in tens of minutes, what it would take us many hours of research. How it works? So here, for specific to OpenAI, it is powered by a special version of OpenAI reasoning models, the OpenAI O3, the O3 model, that has been fine-tuned for web browsing and data analysis task. So what they do, so it follows usually the same steps: so decomposing overall task, planning, sub-questions, gathering resources, analyzing, combining insights, and producing the final output on the report. Right? And the report usually you can download it into a PDF file. The tools that they use is very often is a search engine, a web browser, and then you can read like PDF documents, images, and text. So they say that the use case are for like the professionals who need in-depth research, finance, science, policy, engineering, etc., or high-stake decisions, buying a car. So I don't know if I will talk at the end if you can really you will agree with that. But this is what they say. This is from Gemini. So I skip that. It's the same thing, right? They just the implementation could be a bit different, right? Because they don't publish exactly how they do it, right? So the way they do it could be different across providers, but roughly it's the same thing. And this is okay. So this is a sample output from Perplexity. So there's also Perplexity DeepResearcher. So here they suggest an example. So the query is how will quantum computing impact cybersecurity over the next decade? Okay, the idea is that the quantum computers are going to be much faster, much more efficient than the classical computers, and maybe they'll be able to crack code, right? The current cryptography might not be robust to quantum computing. So that's why this the result of these questions. Okay, so the answer, so they say, so this is a complex forward-looking questions. So perfect for deep research, right? Because it's not, you need to do some research, look for articles, reports, and so on to come up with a good answer. So there are different steps, 4 steps here. So question decomposition. The system breaks the query into subtopics. Well, you have seen this before, sub-questions, such as what is the state of quantum computing today? What technical breakthroughs are expected in the next 10 years? Which cryptographic systems are vulnerable to quantum attacks? What post-quantum security measures are being developed? Okay, so these are the subtopics that we have to investigate. Then source exploration, so performs dozens of web searches, scanning academic papers, IEEE, archives, industry white papers, government cybersecurity reports or guidelines from NIST, expert blogs, tech policy reports. Okay. So then the step number 3, iterative reasoning. So each finding is analyzed for relevance, recency, and authority. The AI cross-checks the conflicted claims and ranks credible sources higher. And then synthesis, where they compile consistent patterns into a hierarchical summary, like human writing literature review. Then it'd be a PDF file, or a text file, or HTML file that you can download. So that's how it is done. So this here they talk about the final output. So this will be the outline. The report will look like this. There'll be a summary. So say quantum computing is expected to advance rapidly by 2035, accelerating decryption capabilities that threaten existing public key cryptography methods such as RSA and ECC, etc. So you have the findings. And of course, the report will be much longer than that. It could be like several pages. So here the report did 38 web searches and reviewed 182 sources. So for us, if we had to do it, if you had to read the source, you have to spend at least a minute or maybe 1 or 2 to 5 minutes or maybe longer on each sources. So you see that then it's already like more than 3 hours, right? You have to do it by ourselves. Then step 4, export and sharing of the report. Okay, so this is what is currently offered today that you can use. After the talk, you can use it on your favorite AI chatbot. But you have to click on the research option. Often it's not by default. So how did we come up with this deep research? So it's really started with the OpenAI R1 model, the first reasoning models, and then DeepSeek R1, Chinese reasoning model. So why the DeepSeek R1 model was so popular? Because this is open source, right? So this one you can download it. OpenAI is a commercial model, so that you cannot open, right? So DeepSeek was an open source model and was doing reasoning, and reasoning was the model was taught reasoning using reinforcement learning. right? This is also one innovation of the DeepSeek R1 model. OpenAI, we don't know exactly what they do, but they probably use also reinforcement learning. DeepSeek were quite transparent. They published exactly what they did, and they use in particular a technique called like GRPO. So it's the group relative policy optimization that simplifies the reinforcement learning. I won't go into the equations, but basically, what reinforcement learning is that you reinforce a good behavior and you incentivize bad behavior. Right? This is the idea of reinforcement learning. So if the model gives good answer, you give like good +1. Bad answers, you give a -1. This is what we say like reward model, right? So reward the model, the answer is correct, and don't reward the model, the answer is not correct. Even the conditional model, right? So the model is given given answers. Look at the reward and then adjust the way it's going to come up with answers, what we call the policy, right? And so the policy is usually what we call pi. And theta, as you see in that equation, the theta is usually the parameters of the policy. So the policy is going to change at each iteration to the reinforcement learning, right? So this way, the model is learning to become smarter and to learn to reason, right? We tell them this is the way to reason, and we give you like an A if you reason well, you follow the instructions, or you give you a F if you do it poorly. So this is deep research on agents are not totally new. They have been around for a few years. So this like AutoGen is a framework developed by Microsoft. It was done in 2003 to 2023. So it was open source too. So it means like chatbots, conversational agents that you could like parameterize, and that they could chat with each other, right? So it's not exactly deep research, but you could like give them some tasks. So here the example that they give is plot the chart of Meta, the stock of the Meta and Tesla on the graph, right? And then you have to go to Yahoo Finance, find the API, or plot the graph and so on, and they do it autonomously. And what Microsoft has developed recently is like AutoGen Studio that builds on top of AutoGen that allows you to play around with these chatbots without programming. Right. Another earlier like attempt at agents, like autonomous like chatbot, is MetaGPT. So here it's been done more, I think, more in terms of software engineering. So here they have, you see on the graph, you see what humans are doing, right? Let's say to develop a program, right? You do planning, requirement analysis, you develop the architecture, system design, you code and you test, and you have acceptance test, okay? Acceptance check. So with AI, you can do the same. So here they use probably ChatGPT, and you have a product manager that can write or read reports. That can reports in Adobe Acrobat for PDF files. Then a system design, so design the system, have a product manager, the code, use Python to code, and then you have QA engineer, so it is also an agent that validate the code. Right? So this is something that people have tried to do for a while. So this was last year. So this year, so we're really like these AI agents and deep research agents have really started to grow a lot. So this is like a Search R1. Search R1 is typically, so you look at this graph, it looks very similar to what you saw before with DeepSeek, right? So this is really basically, to summarize, it's DeepSeek R1, right? Using reinforcement learning to teach reasoning. Plus, you add a search engine. That's what you see in the graph, in the blue box, your search engine. So the thing, you have the policy. So you take the search engine out, it's only the DeepSeek R1 model, right? But you add the search engine, then it becomes Search R1. So here, they use the same method, try to learn to teach the model when to call the search engine and how to use the results of the search engine, right? And this is like the query that you have at the bottom is the query that you use to train the model, right? So they tell, okay, you're going to answer these questions, but you have to format your answer. So you must conduct your reasoning inside these brackets, right? It's think and think, right? Every time you get new information, so you have to think first. After reasoning, you find that you lack some knowledge. You can call a search engine, right? By doing a query. So here, so between brackets, search and search, and you get the search results between information and information. And you can search how many times you want. It can be a cap. And if you find that you don't need any more information, then you come up with an answer between answer, and you come up with the final answer to the question. So this is the format. And the way they train this model, not only they reward the good and the right answer, they reward also the good format, right? So they really want these models to come up with this kind of structure, right? Think, search, come up with information, come up with the answer, go back sometimes if you have to go to look for more information. And that's why when you use Claude, OpenAI, the format looks quite similar too, right? It's usually that you have these things. Also this, okay, something I didn't say for. So this search R1, they get rewarded at the end. They just look at the answer, right? So this ReasonRAG model is an enhancement on search R1, where they also try to reward during the outcome, right? When the way during the process. Right? So outcome is only the final answer. They look at the process too. So if they have some particular template, or they qualify what are the good reasoning track path and the bad reasoning path, right? And they reward the model, right? So they get rewarded not only for the final answer, but also the way they come up with the answer, which is fair, right? Like when you do, for a student, you do math. Sometimes you don't just give a grade for the final answer. You have to see, okay, how did you come up with the answer? What was your reasoning, right? And you get the full mark, right? You show your reasoning. So this what we saw before were like more like single agents. The DeepSeek or search R1 or ReasonRAG. There have been attempts, and then and you know that Claude, they say it's a multi-agent system, right? You can do a deep search agent with a multi agents, so several agents. So typically, one agent will be attached to one model, one Quinn model or OpenAI model, right? So one brain for each agent, and they work, they cooperate. So here that ManuSearch model. So he's using three agents. So the solution planning agent. So planning means like you think in terms what are the different steps to come up with the answer. It's a search agent, right? So you are going to design the query and send the query to the search engine. And then you have a web page reading agent. So you have an agent that reads the answer from the search engine and try to make sense of what it is, right? So do you see the graph shows the planning agent, right? You say, okay, it has three steps. So this is, let's say, the question is like, do the bands BBC Philharmonic and Torch Song originate from the same country, right? So the planning agent say, okay, to answer these questions, what do I need to do, right? So that to see to which band, so family, Torch Song, which country they come from, and then at the end say, are they from the same country, right? And then for each query, they have to go to search the internet, BBC, they probably come from England, and the Torch Song, who are they, where do they come from? They come up with the answer, they come back, and then they come up with the answer, right? Maybe I'm going to. Okay, so this is so another example of a deep research deep research model using multi agents, right? So it's also using a search engine, on the browsing engines, right? So you have the search engine, but you have also to look at all the different answers, right? If you look at Google, Google will give you like many links to different answers, and then you have to select which one is a good one. Okay. To extract the relevant information, right? So Google will give you if you use Google search or Bing search, give you a lot of information, a lot of web pages, but then you have to find which is the right one. And this is also trained by reinforcement learning. EvolveSearch, so it's a variation of these previous models, but the innovation that what they do here is that they before reinforcement learning, things were trained by what they call supervised learning, right? Supervised fine-tuning, right? So you have a core model that like open source model, like the Qwen model or Llama 3 model, and then you specialize on some specific task using what you call SFT, supervised fine-tuning, using a few examples, right? Examples of questions and answers, right? So what they call fine-tuning. But that's a fine-tuning by itself doesn't work very well because you have to anticipate all the questions, answers, and all the way to come up with the answers possible, right? To have a complete model, right? And this is very difficult. Right? So for example, if let's say research takes, like say, 10 hours to complete, it's very difficult to have the path, to define the path in advance of during these 10 hours what the model is going to do. And what is fine-tuning is doing, like supervised learning, means that you have to give exactly the path, the way to come up with the answers, right? So the longer, the more complex is the task, the more difficult is to do it with fine-tuning. Okay. So we say why they are looking at fine-tuning, because RL has also some weaknesses too. So RL some weaknesses is that sometimes it doesn't use all the data available. You will sometimes converge to an answer quite quickly, do some iteration and come up with the answer. So there might not be enough exploration of visiting all the possibilities. So these researchers from EvolveSearch had the idea of combining the two. Okay, so we'll use supervised fine-tuning to give like a rich family of examples that RL and reinforcement learning can use. Then RL can also generate some good reasoning paths, or what they call rollout data that they can feed back to the SFT model. Right? So this model used by iteration, they do SFT, then do reinforcement learning with new raw data from SFT. Reinforcement learning identify a good path that they refeed into the supervised fine-tuning. So this is kind of an interesting way to do it. I find that it improves. Okay, so these are kind of examples that we can guess that Claude, OpenAI are using these types of model, right, under the hood, right? But we don't know. But it's very likely that it's quite similar. And all the researchers from OpenAI, they go to the same conference, they read the same papers, and so you get also the same ideas, right? So how do we know if these models are any good, right? So usually we use benchmarks, and so there are a lot of benchmarks. So I just picked a few ones, but there are a lot of them. So GPQA. Typically maybe GRE level or PhD level science questions. So here, for instance, you see the examples, it chemistry questions. So just read the beginning. So reaction of a liquid organic compound. Reaction of a liquid organic compound, which molecule consists of carbon, hydrogen atoms, is performed at 80 centigrade on 20 bar for 24 hours. Okay. In the proton nuclear magnetic resonance spectrum, the signals with the highest chemical shift of the reactant are replaced by a signal of the product that's observed about 3 to 4 units downfield. Okay, so this is a very technical question, so I probably wouldn't be able to answer the question myself. And then you have, say, A, B, C, D. So you have typically a database of questions of this type and answers in biology, physics, and so on, usually by experts, probably by professors or PhD students. And so they have questions writing, expert validations, question revision, and non-expert validation, and you see, how likely are people able to answer these questions. So you see the experts have a 65% accuracy. So they get it right two-thirds of the time, right? Non-experts, like us, if it's not your field, right? I'm not a chemist, so I'm not an expert, will be 34%, right, of accuracy, right? Which is very likely, maybe 0%. And so these models are trained, are evaluated on this, and of course they don't get to see these the answers, right? The big problem of this kind of benchmark is leaks. Like somehow they might get hold of the right answers and fit their model with that, right? So there's always the risk, right? So this is of data leaks. GAIA is the same thing, uh, but it's not specific. It's not specific to science. It's more to evaluate general AI assistants. And you see so Jan LeCun is one of the co-author, and when in his talk he always says that babies are very smart, are smarter than machines, and you don't need all this data. You can learn. Humans can learn a lot of things, are very smart without like a lot of like training data and so on. So the idea is that a lot of like human tasks are difficult for machines, but easy for us, right? So here, so that you see like there are different levels of questions. So the one in the middle is like, in this whole paint is made of ice cream. How many percent above or below the US federal standard for butterfat content is it when using the standard as reported by Wikipedia in 2020? So as plus or minus a number rounded to a one decimal place, right? So it means that you have to read the label, okay? Then you have to go to Wikipedia, look for the US federal guidelines for butterfat, compare the two, and do the difference, right? So this is kind of a calculation that the agent will need to do on the level 3, and so you can read by yourself. But yeah, and the capabilities required to solve the GAIA problems. You see that a lot of it is web browsing, but you're going to Wikipedia. Sometimes coding. Multimodality means you have to read text, but also something else. So here, for instance, for the label, you have to read, able to understand the picture, right? File type reading, PDF file, PPT, and so on, and identify. So this kind of also kind of test. So they call it the HLE. It's a very grand name for database. Humanity's last exam, right? So I don't know. It means that if AI pass this exam, we are doomed. I don't know. No more exams for us. So it's a challenging language model benchmark that has 2,500 questions across diverse subjects, developed by Center for AI Safety and Scale AI. So it was in response to concerns that the existing benchmarks have become saturated. Saturated means that all the modern models like score 100% or 99% answers. It means saturated. So either they're very smart or all the answers are out there on the web already, right? So they come up with questions. You see different subjects. The best question got money, right? And they're supposed to be difficult, and indeed they are, right? This is a sample questions. So this is I'm not sure it is math or computer science. Not computers, it's like math. It's a graph, the age, and it's a Markov chain, and you have to come with the answer and answer. So these are kind of quite technical questions. So there's a private data set to test, and then they evaluate this. Interestingly, I was looking in Wikipedia, I don't know if it is accurate, that many answers, in fact, in the database were wrong. So they had to correct that too. So it's not easy. So the more difficult are the questions, even to come up with the right answer is not difficult. It's not easy, even for experts. So that I think they probably overcome this. This is another benchmark. Okay, maybe I drop this one. So this is like a benchmark used. So you see that for the less the human humanities last exam, there's a lot of web search, right? So the capability that you want to evaluate is to be able to do a web search, right? To find to use the web, right? So that's why they have designed this WebArena, and there are many other like benchmark of this type. So WebArena is designed to test and improve capabilities of agents, autonomous agents in interactive environments, right? So they need to perform complex tasks such as planning, tracking states, preventing from errors, breaking down tasks, manageable subtasks. So they have a web environment, and you have to be able to interact with the environment, right? So you have to go to Reddit, GitLab, GitHub, use toolboxes, calculators, Wikipedia, etc. And so the benchmark has 812 tasks, 12 examples. And there's also the right answer, right? They say, we'll go to this repository and find the line of code sitting there and see if they're able to do it, right? So when they tested GPT-4 at the time, this is done last year, success rate was less than 15%, right? So it was quite low. So it's not that trivial, right? So I think the same team that did WebArena or did something similar to WebArena, they come up with something. So this is like done this year, agent company. So they try to evaluate them on real world task, right? So using the terminals, using code in Python, do code release, analyze the spreadsheet, do sprint planning. I guess is no, for when they work with software, so for agile methodology to manage like software teams, do travel bits and so on. So it's really like how do you replace humans, right? How do you replace engineers and so on, or technicians, secretaries, and so on? This is what they call agent company, right? So so the most competitive agent could complete 30% of the task autonomously, right? It's low and high. It's not, it's less than 50%, right? But it's so here I think it's Gemini 2.5 Pro, right? Could do 30%, but you can imagine that this year, next year, it'll be 50%, then 70% and higher. Who knows? BrowseComp, this is done by this is like a web browsing benchmark. It was done by OpenAI, right? Like to evaluate the own model. Interestingly, they find that humans, in fact, are not that good. They said that human trainers had a low success rate, less than 29%. And I think one of the most recent OpenAI model has a success rate of 50%. So in fact, OpenAI model for browsing, just for browse the web, they are outperforming the average human, right, by 20 points. So it's not that, so it's kind of interesting. It's not that the humans are necessarily at 100%, only 9%, right? Some tasks, the humans are not that great. Okay. So this so this is also like I want to finish on this before talking about risk and limitation. This is like also a recent model that's also using reinforcement learning, GRPO, but that does something a bit different. Is that very often these agentic models, they are either trained separately and they're not trained at all, right? They're just they use out of the box model and they try to prompt these models to try to make them work together, but sometimes there's no full training. Or sometimes there's a training trained independently on the separate data, and they just assemble at the end, right? So here, what they suggest that if you train them doing like from end to end, or you train for the whole task, you get better performance, right? So here, what they do, they don't train all So here there are like 4 agents. It's multi-agent model. There's a planner, executor, verifier, and generator, right? So planner is what we saw before. You like to think of what are the sub questions to have to answer, right? To come up with the answer is the planner. Executor is like how do I how do I get the answers? Verifier, there's an agent that verifies the answers, and there's a generator that generates the reports. So what they do, they train the planner, but across the whole flow, right? The planner gets rewarded. The answer at the end gets correct, right? Uh, so so this used what they call like flow reinforcement learning. So this kind of same idea as reinforcement learning, right? Uh, you have reward, you have what they call advantages. So this is what you want to maximize, and you want to change your policy, right? To improve your policy, and at the same times. You want to have a stable behavior, means that you don't want the new policy to deviate too much from what they call the reference policy, right? And they use what they call KL, that KL divergence, right? So it's a typical like GRPO, but they do it across all these different rollouts. I wanted also to mention before going to risk and limitation, 2 things that you should know, you must have heard before, but these are interesting things that should be interesting to know. MCP and A2A, right? So MCP is a model context protocol, right? So it's an open standard. I think it's proposed by Claude for agents to interact with tools. So tools we saw like search engines, but it could be calculator, it could be database and so on. But a standard way so that you can plug in an agent, and plug in a tool, and they'll be able to talk together. Right? So it's just like that protocol, MCP, and that has become very popular. So because before people had to do their own thing, and then you have to reinvent the wheel each time you use a new tool, a new agent. But this, as long as you know how to use MCP and your agent had to query MCP, the tool had to know how to connect to MCP, they can talk to each other. Right? So this is a very powerful tool. There are some weaknesses, there's some problem with security and so on, but the idea is very good. And then you have A2A, this is from Google. So this is not for agent to tool or tool to agent, this is for agent to agent, right? We saw a MetaGen before from Microsoft. This is from Google. So it's also a protocol for agents to talk to each other, especially if the agents are not from the same company or the same organization, right? So you could have a supplier that using agents, to take your orders, or you have a inventory agent in your company that look at inventories, and then they need to communicate to each other, right? The inventory agent is going to talk to the supply agent and say, okay, I need these new products, this and that. But now there's a protocol, and they know how to talk to each other, right? So this is quite interesting. So it's all standardized. There's security, opacity, and so on. So you don't have to expose your code and so on to another company, there's another organization, or you don't know them. Okay. So I'm almost done. So I just want to talk about the risk and limitations. So a lot of risk and limitations are not specific to deep research agents. That's just typical to AI. There could be a privacy, security, and so on. This is you're faced with a deep agent. So here I've been asking OpenAI on the Claude what were their own limitations. Right? So what they say. OpenAI is on the left. So deep research, we're going to call DR. So DR has important caveats. They struggle to distinguish authoritative information from rumors. Right? So for example, you go to Reddit or you go on the web, you can have all kind of crazy information, right? It could be, is it authoritative or not, right? And sometimes it's not because like a link has a lot of clicks that is necessarily authoritative, right? It could be that it's a famous person that says some crazy things and got a lot of clicks, for instance. Right? So it might treat the less credible blog or forum as though it were a peer-reviewed paper. right? So some peer-reviewed papers might have no but because too technical, somebody is going to read the paper. But the blog written in English from a popular maybe Joe Rogan or someone like that might get a lot of views, right? And then the AI might get confused and say maybe the Joe Rogan post maybe it's more authoritative than the paper from a peer-reviewed paper. Hallucination can still happen. So OpenAI says that, right? Uh, Even with lower rates, deep research can still make up facts, misinterpret sources, or draw faulty inferences. For example, some user reports say that deep research generated plausible-looking but incorrect company profiles or citation. Right? One commenter said even suggested fake contact emails, domains that aren't even registered. So this is for OpenAI deep research. Right? Confidence, uncertainty, calibration. Deep research currently struggles with confidence calibration. So when they say they're high confidence or low, medium, low confidence, right? So then you see the output, you see the medium, means a medium confidence. We often fail to convert uncertainty accurately, right? So it means that when they say high confidence, you shouldn't be high confident that it's really high confidence, right? So you have to be careful. New or niche information might be missing. So use browsing or existing resources. It's much better than before, right? You remember the early iteration of OpenAI? It was trained before with data before, let's say, 2023, then you wouldn't know anything happening after 2023. Not even who is the current president, right? So this is much better. That you can browse the web, but still you might not have the most current information. Might be able to access, let's say, Bloomberg or this kind of website with paywalls, right? So this kind of risk. So there's also, I put the quote also for Claude is basically said the same thing, right? So it said you have to review the cited resources and so on, and there can be mistakes in the report. And then something that happened last week, 2 weeks ago, Deloitte in Australia, right? They produced a report for the government, for the Australian government, on some for I don't know, welfare reform or something like that. And there are a lot of like wrong citations that didn't exist. And they cited a researcher that wrote a book that she never wrote on a topic that she never studied, right? So it was flagged, and so some people are asking for the money back, and they charge something like so I don't know these are like Australian dollars or US dollars, but the numbers of $300 to $400,000 for the report. But they disclose that they used Azure OpenAI, in fact, to write part of the reports, right? So so this is kind of embarrassing, right? You can that you have, you get into the news, government asking for their money back, you have wrong citation and so on. So deep research is great, but you have to be very careful and double check the results, citation, answer very, very, very carefully, right? You cannot just do the search, export on PDF and publish it and sell it to the Australian government. So future direction and conclusion. So future development. So this is like there's a lot of surveys you can find on archives. So this is one survey. So they talk about possible directions for future research. So better reasoning models, right? So the kind of ways like they can reason better, make better plans. So reasoning usually happens using the planning, also happens during the understanding the report or the results from the web. But for instance, if you have very long queries, usually experience shows that the queries are very long, they're more likely to get it wrong. I mean, they search for too long, they might get confused because there's too much information and they might not get the right answer. So there's still improvement on reasoning. And the hallucination, right, is still a big problem. Why it's not acceptable that they cite wrong things, right? So this is something that should be fixed, right? If you see citation from like we get a result from Google, an answer, usually it's a real website, right? Google never give us a wrong URL, right? I mean, at least it has never happened to me, right? So you should expect the kind of some kind of reliability. They say citation, the citation should be 100% correct. It's not acceptable to have any errors in there, right? So there's still work to be done. Then talk about multimodal deep research. A lot of research done on text, but now you look at images, videos, and so on. So now they should be able to do research on text and videos and so on. Then a lot of companies now are working on domain-specific optimization. So deep research agents for specific industry, what they call verticals, right? So it could be science, biology, physics, astronomy, and so on, finance, law, and so on. A lot of startups are doing that. The fourth thing is like I'm less familiar, but it's more like how do you work along with these deep research agents? How humans and AI interacts? How do you manage them, right? So maybe tomorrow we'll have teams, hybrid team of human researchers, and AI researchers or AI assistants, right? And how so you might get a report from AI, a report from the humans, and combine the two. They might have to work together. How get the best of the two? How do you do that? And so on. So these are some stuff for research. So these are for the future research. So, in my opinion, I think it's still a very useful way to do it. I mean, to have the alternative, what we had before was just you ask a question to OpenAI, give you an answer, and you have no clue where the answer came from. So at least now they reason, you see how they come up with the answers, they look at the sources and so on. So you have much more background information. So the answer should be more reliable. It's not 100% reliable, but it's much better than before. So this is progress, right? It's probably, maybe it's not always the case, but maybe this is my opinion. It's very more useful for people who know something about what they're looking for. You have the level of knowledge. If you're a biologist and you get some deep research in biology, then you're more able to see that some results are wrong, citations are wrong, that people don't exist, that also you have some knowledge of the field. It's much easier to verify the results, right? If I don't know anything on a topic and I do a query, how am I going to be able to verify the report, right? So maybe that's why it's knowing something is better than to know nothing, right? So it's this is my opinion. So there's still risk and limitation. We talk about hallucination. You see that they try to do also to make a multi-agent system and so on. So Claude is using a multi-agent system. But we have to think that the more complex the system, the more the risk of failure, right? You can have one bad agent, an agent that is very weak. It might mess up all the results, right? So that's what they said. No, the strength of the chain is the weakest link, right? So it could be true. At least it is linear. Maybe a way to address that is to have it in parallel, to have several agents, maybe several weak agents working together. Maybe they might cancel each other. Maybe the result might be stronger. Maybe it's diversify across agents could be a possibility, or make the agents stronger. A way to also to audit if there's a problem. They say results is wrong. We need a way to know where does the problem come from. So when Claude gives the wrong results, we don't know, right? We don't know why. For instance, for Deloitte, right, for the Australian reports. So they're going to ask OpenAI, okay, why the results, why the citation were wrong. OpenAI has to be able to audit. Ideally, Deloitte should be able to audit why the results was wrong, right? So the citation is wrong, and what caused that? Okay. Okay, so this is just for my book. So this is the first book. So I've written 3 books on agents. So the first book has been published earlier this year, January this year. I'm working on the second volume. So a lot of what you've seen today will be in the second volume. So I'll talk about the AI agents in general. So deep research agents. I'll talk about AI scientists, research in science. Talk about research that has been done in RAG, knowledge graphs, and so on. A lot of summarized sort of research that has been done this year. And so I said part three will be when we're going to have AGI. So it could be in